Hi everyone, this is the second part of this chapter. We are going to actually talk about security architecture models. Basically, what are they? They illustrate information security implementation, and actually they can help a company make quick improvements through adaptation. Formal models are not going to be used directly, so the companies need to actually make changes and adopt them in the organization as see what they can use. Some models, they focus on confidentiality of information, but other models, they can focus on integrity of information as it's being implemented. So the first model that we can talk about is trusted computing based, or what we call it the TCP. So the Trusted Computer System Evaluation Criteria, that's what we are going to talk about, is an older U.S. government Department of Defense standard that can define the criteria for assessing the access control in a computer systems. This type of standards is part of a larger series of standards that sometimes they call them Rainbow series. You can actually go and look more about the Rainbow series and why they call that, because that's due to the color coding that is being actually used to identify each document. Also, the Trusted Computing System Evaluation Criteria is also known as Orange Book and is considered the cornerstone of these series. The TCSAC was replaced by the Common Criteria in actually year of 2005. As you know that if you are working in the field of IT or security, you always need to be familiarize yourself with the legacy system. So we need to kind of understand the legacy approach. We need to kind of understand that Orange series approach before we can adopt the new term Common Criteria. So the TCP is actually made up of hardware and software that has been implemented to provide the security for a particular information system. This usually includes the operating system kernel and a specific set of security utilities such as the user login. The term trusted sometimes can be misleading. It means that a component is part of a TCP security system, not that it is necessarily trustworthy. Within the TCP is a conceptual object that is known as reference monitor to mediate access to the object by the subjects. So system administrators, they should be able to audit or periodically review the reference monitor, making sure that it's functioning effectively without unauthorized modification. One of the biggest challenges in TCP is the existence of covered channels. Covered channels are unauthorized or unintended method of communication that's hidden inside a computer system. Basically, some of these researchers, they discovered that those indicators like blinking on the some of the network routers were basically flashing in sync with the content of data that is being transmitted. That was just unintentionally displaying the content of the data. So the TCSAC defines two kinds of covered channels. One of them is storage channels, the other one is timing channels. In the storage channels, which communicate by modifying a stored object, and in the timing channels, which transmit information by managing the relative time of events. For example, in a system that places a long pause between packets to signify 1 and a short pause between a packet to signify a 0. Now let's look at information technology system evaluation criteria. which is an international set of criteria for evaluating computer systems. This is also very similar to the TC-SEC that we talked about. Under ITSEC, targets of evaluation, or we call them TOE, are compared to the detailed security function specification, which is going to result in an assessment of system functionality and comprehensive penetration testing. Like TC-SEC, ITSEC was for the most part replaced by also the common criteria as well. ITSEC also rates the product on a scale of E1, lowest level, to E6, highest level, the same way as TC-SEC and common criteria do. So now let's look at the common criteria. The common criteria for information technology security evaluation is sometimes called CC, or, as we said, common criteria. This is also an international standard that was developed by ISO 15408. So it is kind of considered the successor of both the TC-SEC and ITSEC, and it also reconciles some of the differences between various other standards. So the common criteria is a combined effort of contributors from Australia, New Zealand, Canada, France, Germany, Netherlands, UK, and United States. The CC process assured that the specification, implementation, also evaluation of computer security products are performed in a rigorous and standard manner. Now let's look at economic access control model. There are a number of access control models that we talked is designed to teach system designers to build operating system with the security built in, by making sure that you control the confidentiality and integrity of data within the software. Some of these were built into actual operating system, but most of them were simply used to better understand how systems should or could function. Let's look at Bell LaPadula confidentiality model, which is kind of a state machine reference model that making sure that the confidentiality of the model system by using the max data classification and security clearances. This state machine model is one in which the design follows a conceptual approach in which the state of the content of the system being modeled is always in a known secure condition. In other words, this kind of model is provably secure. We can say that. So in this type of confidentiality model, which is known as a state machine reference model, a system that serves as a reference monitor compares the level of the classification of the data with the clearance of entity that is requiring the access. It can allow access only if the clearance is equal or higher than that classification which is requiring to have access. BLP security rules prevents information from being moved from a level of higher level security level to a lower level of security. Access modes can be one of these two types of security: simple security or star security. The simple security also is called read property, which prohibits a subject of lower clearance from reading an object with a higher clearance, but it allows a subject with a higher clearance level to read an object from a lower clearance level, which we call it a read down. The star property, or the write property that we can say, prohibit high-level subject from sending messages to a lower-level object. In short, this principle is no read up or no read down. So this star security is basically no read up or no read down. Now let's look at BPA integrity model. BPA integrity model is another state machine model that is similar to the BLP that we just talked about. The intent is to provide access control to ensure that object or the subject that cannot have less integrity as a result of read-write operation. The Biba model assigns integrity level to subject and object using two properties: the simple integrity or read property and the star property, which is the write property. Again, the simple integrity property permits a subject to have read access to an object only if the security level of the subject is either lower or equal to the level of the object. The star integrity property permits a subject to have write access to an object only if the security level of subject is equal or higher than of those objects. In short, again, there is no write up or no write down. We have another model which is called Clark-Wilson integrity model, which is built upon principle of change control rather than integrity level. And this was designed actually in a commercial environment. The change control principle which it can operate are basically no changes by unauthorized subject, no authorized changes by authorized subject, and the maintenance of internal and external consistency. So what do we mean by internal consistency? It means that the system does what is expected to do every time without any exception. External consistency means that the data in the system is consistent with similar data in the outside world. The intent of this model is to provide an environment where security can be proven through the use of separate activity, in each of which provides security. These controls are part of CWI or Clark-Wilson model: subject authentication and identification, access to object by means of well-formed transaction, and execution by subject on a restricted set of programs. The elements of Clark-Wilson models are constraint data item, which is data item with protected integrity, on constraint data item, data not controlled by Clark-Wilson, and integrity verification procedures that scans data and confirms its integrity, and also transformation procedures that allow changes to a constraint data item. We also have another model. Just remember, you don't have to know all of these, and maybe these are a lot. Just know that they are other control models that are out there, and remember, these are the academic access controls. The other one is also Graham-Denning access control model, which has three parts: a set of objects, a set of subjects, and a set of rights. So the subjects are comprised of two things: a process and a domain. The domain is basically a set of constraints that are controlling how the subject may be accessed, that object. There are 8 primitive protection rights: create object, create subject, delete object, delete subject, read access right, grant access right, delete access right, and transfer access right. Then we have the Harrison-Russell model, or HRU model, which define a method to allow changes to access right and the addition and removal of subject and object, a process that the Bella-Padula model doesn't do that. Since system changes over time, their protective state needs to change as well. HRU is built on an access control matrix, and it includes a set of generic rights and a specific set of commands. Basically, create subject, create object, enter write X, delete it, destroy subject, and so on. Brewer-Nash, or another word is a Chinese wall, that's very common word for it, is designed to prevent a conflict of interest between two parties. The Brewer-Nash model requires user to select one of the two conflicting set of data, after which they cannot access the conflicting data. One example for that would be maybe a law firm that needs to represent two individuals who got involved in a car accident. One sues the other, and the firm has to represent both. To prevent the conflict of interest, the individual attorney should not be able to access the private information of the both people. The Brewer-Nash model requires user to select one of two conflicting set of data, after which they cannot access the conflicting data. We also, now we can look at other security management models that are out there. These are the famous one. One of them is ISO 27000 series. So we will discuss more in depth about the ISO 27000 and also about other models such as NIST security models and as well as ITIL in the next part of the chapter. For now, this is it. So please watch the next video. Bye-bye.